The National Electrical Code, or NEC, specifies requirements for switchbox placement. Regarding the height from the floor, switchboxes must be installed at least 48 inches from the finished floor to the top of the box, according to NEC section 380.14a. However, there are exceptions. Firstly, switchboxes installed in hallways, stairways, and corridors may be installed at least 36 inches from the finished floor to the top of the box, per NEC section 380.14 Bowen. Secondly, switchboxes installed in alcoves or other locations where the switch would be obstructed by furniture or other objects may be installed at less than 48 inches from the finished floor, as detailed in NEC section 380.14 B2. Now let's consider a practical application. If the pass-through height is 41 inches, which is less than the minimum height of 48 inches from the finished floor to the top of the box, the code might not allow installation of a 3-switch box below the pass-through at 38.5 inches from the floor to the top of the box, depending on local jurisdiction interpretations and specific conditions. Addressing such situations involves alternative solutions. One option is to raise the pass-through height. Increasing the pass-through height to at least 48 inches would accommodate proper switchbox placement. Another solution is to install the switchbox in an adjacent wall, ensuring it's positioned at least 48 inches from the finished floor. A third option is to install a remote switch. Using a wireless or remote-controlled switch allows for placement at a convenient height and location, circumventing the physical limitations. The NEC is a comprehensive set of standards. Electrical installations must adhere to these standards to ensure safety and compliance. Always consult the latest edition of the NEC and local amendments for the most accurate and up-to-date requirements. The NEC is updated regularly, typically every 3 years, to reflect changes in technology, safety practices, and industry standards. Local jurisdictions may also have their own amendments to the NEC which must be followed. Understanding the NEC requirements for switchbox placement is crucial for electrical contractors and homeowners. Proper installation ensures safety and compliance with local codes. The 48-inch minimum height requirement is intended to make switches accessible to people with disabilities. The exceptions for hallways, stairways, and corridors are based on the understanding that these areas may have limited space. The exception for alcoves and other obstructed locations is intended to allow for flexibility in situations where the standard height would not be practical. Consider other factors such as the placement of furniture, the location of other electrical devices, and the overall design of the room. Always consult with a qualified electrician to ensure that electrical work is done safely and in accordance with all applicable codes. An electrical permit might be required before starting any electrical work. The inspection process ensures that the work meets the requirements of the NEC and local codes. The type of wiring used, the size of the circuit breakers, and the grounding system all must be inspected. Failure to obtain a permit or to comply with the code can result in fines or other penalties. When choosing a location for a switch box, ensure that there is sufficient space to install the box and to run the wiring. Avoid locations where the box would be subject to damage or moisture. Use appropriate hardware and tools when installing the switch box. Ensure that the box is securely mounted to the wall or ceiling. When wiring the switch, follow the manufacturer's instructions carefully. Use properly sized wire and connectors. Make sure that all connections are tight and secure. After completing the installation, test the switch to ensure that it is working properly. Use a voltmeter to check the voltage at the switch. If there are any problems, consult with a qualified electrician. Remember, electrical work can be dangerous. If not qualified, hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes. The NEC covers a wide range of electrical topics. These topics include wiring methods, overcurrent protection, grounding, and equipment installation. It is important to understand the NEC requirements for each of these topics. Many online resources are available to help learn more about the NEC. The NEC is a complex document and it can be difficult to understand all of its requirements. However, it is essential to have a basic understanding of the NEC in order to perform electrical work safely and in compliance with local codes. The NEC requirements for switchbox placement are designed to ensure safety and accessibility. It is important to understand these requirements and to follow them carefully. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. The NEC addresses various aspects of electrical installations beyond just switchbox heights. Firstly, consider wiring methods. The NEC specifies approved wiring methods for different applications. These methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. The choice of wiring method depends on factors such as the environment, the type of building construction, and the voltage and current levels. Secondly, overcurrent protection is addressed. The NEC requires overcurrent protection devices such as circuit breakers and fuses to protect electrical circuits from overloads and short circuits. The size of the overcurrent protection device must be properly matched to the ampacity of the circuit conductors. Thirdly, grounding is crucial. The NEC requires electrical systems to be properly grounded to protect against electrical shock hazards. Grounding provides a low impedance path for fault current to return to the source, causing the overcurrent protection device to trip and to energize the circuit. Fourthly, equipment installation guidelines are provided. The NEC provides detailed requirements for the installation of various types of electrical equipment, such as lighting fixtures, receptacles, and appliances. These requirements are designed to ensure that the equipment is installed safely and in accordance with the manufacturer's instructions. The NEC also addresses special occupancies. Special occupancies, such as hazardous locations, healthcare facilities, and places of assembly, have unique electrical requirements. The NEC provides specific guidance for these occupancies to address the increased risks associated with these environments. Additionally, the NEC covers emergency systems. Emergency systems, such as backup generators and emergency lighting, are designed to provide power and illumination during power outages. The NEC provides requirements for the installation and operation of these systems to ensure that they function reliably when needed. The NEC also covers low-voltage systems. Low-voltage systems, such as fire alarm systems, security systems, and communication systems, are also addressed. The NEC provides requirements for the installation and wiring of these systems to ensure that they operate safely and effectively. The NEC is constantly evolving to keep pace with changes in technology and industry practices. Regular updates and revisions are made to the NEC to address new hazards and to improve the safety of electrical installations. It is important to stay informed about the latest changes to the NEC and to ensure that electrical work is performed in accordance with the most current requirements. Understanding the NEC is essential for anyone involved in electrical work, from electricians and contractors to engineers and inspectors. The NEC provides a comprehensive set of standards that are designed to protect people and property from electrical hazards. By following the NEC requirements, electrical professionals can help to ensure the safety and reliability of electrical systems. The information provided here is not exhaustive. It is intended to provide a general overview of some of the key topics covered by the NEC. For more detailed information, refer to the latest edition of the NEC and consult with a qualified electrical professional. Furthermore, understanding voltage drop is crucial in electrical installations. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its impedance. Excessive voltage drop can cause equipment to malfunction, reduce the efficiency of lighting, and overheat conductors. The NEC provides guidelines for calculating voltage drop and for selecting conductor sizes that minimize voltage drop. The NEC also addresses the use of arc fault circuit interrupters, or SIs. SIs are designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when insulation breaks down or when conductors become loose. SIs can detect arc faults and quickly de-energize the circuit, preventing a fire from starting. In addition to size, the NEC also addresses the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock hazards. GFCIs can detect ground faults, which occur when current leaks to ground, and quickly de-energize the circuit, preventing electrical shock. The NEC requires GFCIs to be installed in certain locations where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. The NEC also covers surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. SPD divert the surge current to ground, preventing it from damaging sensitive electronic equipment. The NEC provides requirements for the installation and wiring of SPD. Additionally, the NEC addresses energy efficiency. The NEC includes provisions that promote energy efficiency in electrical installations. These provisions cover topics such as lighting controls, motor efficiency, and power factor correction. By following these provisions, it is possible to reduce energy consumption and lower utility bills. The NEC also covers renewable energy systems. Renewable energy systems, such as solar photovoltaic or PV systems and wind turbines, are becoming increasingly popular. The NEC provides requirements for the installation and wiring of these systems to ensure that they operate safely and reliably. These requirements cover topics such as grounding, overcurrent protection, and disconnecting means. The NEC also addresses the use of data communication cables. Data communication cables, such as Ethernet cables and fiber optic cables, are used to transmit data signals in buildings. The NEC provides requirements for the installation and wiring of these cables to ensure that they do not create electrical hazards. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. Regular updates and revisions are made to the NEC to address new technologies, improve safety practices, and clarify existing requirements. It is essential to stay informed about the latest changes to the NEC and to ensure that electrical work is performed in accordance with the most current requirements. Understanding the NEC is a continuous process. The NEC is a complex and comprehensive document. Electrical knowledge is not only knowing the current codes but all past codes and accepted engineering practices. With all the code articles, tables, and definitions, it is important to have a good base understanding of the electrical theory. The NEC is not designed as an instruction manual but gives only bare minimum accepted best practices. Electrical science must be understood and continually learned.